Right? And we said when you have a question like this, what we do is just to expand. So we take this what is outside to multiply what is inside the bracket. So 5 multiplied by x, we get 5x. 5 multiplied by negative 4, we get negative 20. It's lesser than 3 multiplied by 12, we get 36. And 3 multiplied by x, we get minus 3x. So the next is to collect like terms. The next is to collect like terms. So by so doing, we will eventually have 5x. Then we bring this negative minus 3x to this side, become plus 3x. It's less than. After this, the next question you're going to do, okay? 36. Or it's okay, right? We bring minus 20 to this side, become plus 20. After this, you can do, right? Right?
Depends on the question.
Okay. So we add this and this together, we get 8x is less than. We add this and this together, we get what? 56, right? Then the next is to divide both sides by 8 so that we can find x. Divide both sides by 8 so that we can find x. So I divide here by 8, divide here by 8. So 8 cancel 8, we have x left on the left. It's less than 56 divided by 8, 7, right? 56 divided by 8, we get 7, right? So x is less than 7. So you can just put in a number line as the case may be. Is that okay? See, x is less than 7 for the inequality solution. So we go to the next question. The next question, inequality, is this one. Is the first question actually. It says solve 9 is less than. Okay. I think I have to do this one. This one is like a double inequality. I have to do this one. Okay, 9 is less than 3n plus 6. 9 is less than question number 10. Question number 10. This is another form of inequality, okay, which we've not treated. So I have to treat this one. 9 is less than 3n plus 6. Nine is less than 3n plus 6, and then lesser than or equal to 21. Find the integer values of n. Is lesser than equal to 21. Lesser than equal to 21. So find the integer values of x. Okay, so we've done the one that includes expansion. We've done the one that includes fraction. We've done the simple one, but we've not done this double inequality. So for this type, what we should do is to like solve them like two separate inequality, and then we merge them in the end. You see this one like one inequality from the beginning of this one to the next one before you get to the sign of the second inequality. We know we have one sign here, and then you also you circle from here also before you get to this second sign of the inequality. So you see we have two inequality. I can split them now. So on the right I have 3n plus 6 is lesser than or equal to 21. This is one inequality, which I will do on my right. In the end, I will merge them again. On my left, I have 9. 9 is less than 3n plus 6. So you see, I split this one into 2. This is called double inequality. I split it into 2, and then we can solve them. And then we merge them after we finish solving them separately. So what I have here, I have 3n is lesser than, you take this 6 to the right, it becomes 21 minus 6. 21 minus 6. So I have 3n lesser than, is lesser than or equal to 21 minus 6 is 15. So you divide both sides by 3 in order to get n. So you say 3n over 3 is lesser than or equal to 15. 15 over 3. So this cancels this, and then we have n is lesser than or equal to 5. 50 divided by 3 is 5. So we get this first side on the right. Now let's do the left part. The left part here we have 9 is less than 3n plus 6, right? So we also collect like terms. So we bring 6 to join the 9. When it comes to the left side, it becomes negative 6 is less than 3n. 9 minus 6, we get 3. So 3 is less than 3n. So we divide both sides by 3 in order to find n. Divide here by 3, divide here by 3. This 3 cancel this 3, we have n left here. And this 3 cancel this 3, we have 1 left here. Okay, so we can merge them together as n and n is same as 1n. We merge them together. We have n is lesser than or equal to 5 on the right, and on the left is greater than 1. On the left is greater than 1. So this becomes the solution to this inequality. This becomes the solution to this inequality. Is that okay? Is that okay?
Yes.
Today you are not writing today. Previously you used to write.
No, because I lost my copybook, so I'll just write it later when I find them.
Okay. Okay, let's take another one. Okay, these are from IGCSE paper, from exam mate. Let's take a look at another question that has inequality. Okay, the first one. So the first one has inequality, and that's it. That's the only inequality for this question. These are algebraic fractions, the one we've done. We've done algebraic fraction. We've done this algebraic fraction. So once we did this inequality, for example, a question comprising of this type of problem is you sure of getting everything here. Okay? Except that recently we've not done the quadratic. Okay? But I'm sure you know how to do quadratic. Okay, let's do this inequality first quickly. Find the integer values for x which satisfy the inequality. Negative 3 is less than 2x minus 1. Negative 3. Question number 11. Negative 3 is less than 2x is less than 2x minus 1 less than or equal to 6. 2x minus 1 is lesser than or equal to 6. This is similar to the one we've just concluded. This is very similar. So I don't know if you want to try this one. Do you want to try? Or you want me to do?
Can you do it?
Okay. So like I said before, you see, I can break it to two inequality. I can break this one into two inequality. Okay. And then here, break it from here like this up to this place. So you see, I can have two inequalities. So I split them. I'm going to write them out separately and solve them separately, then join them together in the end. So I have 2x minus 1 is lesser than or equal to 6. Lesser than or equal to 6. Okay, that's on one hand. On the other hand, we have negative 3 here, lesser than 2x plus minus 1. 2x minus 1. So I have these two inequalities. This one on the left, and then this is the one on the right. This is the one on the right. So we solve them. Let me start with the one on the right. So if I have 2x, I'll take this negative 1 to the right to join 6. So it will be lesser than or equal to, when it comes to this place, it becomes 6 plus 1. Becomes 6 plus 1. So I have 2x is lesser than or equal to 7. So I divide both sides by 2. I divide here by 2, and I divide here by 2. Right? This will become x is lesser than or equal to 7 over 2. If you want to leave it like that, it's okay in fraction. Or you write it as decimal 3.5. 3.5. X is lesser or equal to 3.5. Then we look at the left side. We have minus 3 is less than 2x minus 1. So I bring this minus 1 to join the other side. So it becomes plus 1. So we have minus 3 plus 1, because the negative 1 comes to the left side of this inequality. Is less than 2x. So minus 3 plus 1 is negative 2. So I have negative 2 is less than 2x. So because we're looking for x, we divide both sides by 2. Divide here by 2, divide here by 2. So what we have left, if you divide here by 2, you have x left here. It's lesser than negative 1. Remember, the sign does not change because you are not divided by minus 1. The sign will only change when you are divided by negative 1. So you see, we have x here, we have x here. We merge them together. Let's merge them together. Now we have our double inequality. So x and x, we just write only x. So you write is lesser than or equal to the right, is lesser than or equal to 3.5. And this x is greater than negative 1. So this becomes the inequality. Now, okay, quickly, we show this inequality in a number line. Let's show this inequality in a number line. So what we do, we just draw from maybe negative 2, negative 1, 0, 1, 2, 3, and 4. Obviously 3.5 is at the middle here. So this is the x, put it here. So 3.5, you go here. We say x is lesser than or equal to this, so I have to shade this place. And then negative 1 is greater than negative 1, but it's less than 3.5. So you just join them together like this. If it's double inequality, we just join like this together. Finish. Okay, for double inequality. So this is the number line for this inequality. It's how to show it in a number line for this inequality. 3.5 is here, between 3 and 4, halfway between 3 and 4. That's where you have 3.5. Okay, so that's that for this question. Let's take another question. Let's see. Okay, so sometimes they want you to, after you finish solving, you should list the integers, right? The question wants you to list the integers. They find the integer values for x which satisfy the inequality. Okay, so the integer 0, some people don't write it as integer. Okay, to be honest, 0 is not part of it. But when you say whole numbers, you can include zeros. Okay, so you just list your integers. They must be whole numbers. Since our solution was between -1 and they want positive integers, so we're not going to mention the negative number. So we're not going to mention the because it's between -1 to 3.5. So we say the positive integers 0, 1, 2, and 3. 3.5 is not an integer. It's not a whole number. So this becomes your positive integers, the one that do not have negative. If they just say integer, they don't measure positive integer, you have to include your -1. No, x is greater than -1, so it's not even part of it. So these are your integers, 0, 1, 2, and 3 for this question. Is that okay? Now let's move on quickly. Solve the inequality. 3y plus 7 is lesser than or equal to 2 minus y. 3y plus 7, question number 12. Three y plus 7 I think is greater than, no, it's lesser than or equal to 2 minus y. It's lesser than or equal to 2 minus y. Okay, it's the same thing we're going to do. We're going to collect like terms, right? We're going to collect our like terms. We're going to collect our like terms. So we have 3y. You bring this y on the left to the right, it becomes plus y. 3y plus y is lesser than or equal to 2. Bring this 7 to the right, become -7. Become -7. So you add this and this together, you get what? 4y. 4y is lesser than or equal to 2 minus 5. Sorry, 2 minus 7. You get -5. You get -5. So you divide both sides by 4. Since you are not divided by negative, this will not swap. So you divide both sides by 4, you have 4y over 4. It's less than or equal to -5 over 4. So this cancels this. All we have left is y. It's lesser than or equal to -4 over 5. Okay, you can leave like this, or you put in decimal, become 1 point something, right? Okay, so that's that for this solution. Yeah, they put in decimal. -1.25 is same as 5 over 4. Okay, same as 5 over 4. Okay, another question. X is a positive integer and 15x minus 43 is less than 5x plus 2. Work out the possible values of x. X is a positive integer, so meaning when you finish solving this, you can list out the integers. X is a positive integer and 15x minus 43 is less than 5x plus 2. Question number 13, right? 13. (15x minus 43 is less than 5x, right? It's less than 5x plus 2. 5x plus 2. So we solve this. We collect like terms as usual. So we say 50. The ones that have x, bring them to the left. We say 15x. Bring this 5x, bring it to the left. It becomes minus 5x. Is less than this 2. Bring 43. It becomes plus 43. It's negative 43 on the left. When it comes to the right, it becomes positive 43. So 15 minus 5x, we get 10x. Is less than 2 plus 43, we get 45. We get 45. So to find x, we have to divide both sides by 10. So we divide both sides by 10. Divide here by 10. And then we also divide this place by 10. So this cancels this. We have x left. Less than 45 divided by 10, we get 4.5. So if they say we should list the positive integers, then the integers will be 0, 1, but 0 usually we don't include. 1, 2, 3, and 4. Okay, because less than 4.5. 0.5 is not 4.5 is not an integer. It's not a whole number. Let's see if they want the positive integer. Yeah, s is a positive integer, and this is work out the positive value of x. So these are the possible values of x that we've itemized. Okay, 0, 1, 2, 3, 4. So that's that for that. Let's take another question. As much as we can, right? As much as we can. That has to do with the. Okay, I like this one. This is a fractional one. We've solved similar one like this previously from the Save My Exam. Now let's take a look at this question from here. 2x minus 3 over 5. 2x minus 3 over 5. Question number 14. Question number 14. 2x minus 3 over 5. Then minus 2x minus 3 over 5 minus x over 3 is less than equal to 2. Minus x over 3. Okay, minus x over 3 minus x over 3 is lesser than or equal to 2. Okay, this is similar to what I said before. I said always find the LCM of the denominator to remove it from fraction. Multiply through by the LCM of the denominator, and then the problem will be solved. So what we do is to find the LCM of 3 and 5. 3 and 5, the LCM is 15. Just like you say 5 times 3 or 3 times 5 times 1. So the LCM will be equal to 15. LCM equal to 15. So once we know the LCM, we multiply through by the LCM. So I'm going to have, my LCM is 50, so I say 50 times whatever I have here, 2x minus 3 over 5. Are you with me? Hello?
Yes, sir, yes.
Okay. So we also multiply here by the LCM, which is 15 lesser than 2 multiplied by the 15, which is the LCM. So the next is to cancel, see what can eliminate each other. 5 divided by 5, you get 1. 50 divided by 5, we get 3 here. Now 3 divided by 3, you get 1. 50 divided by 3, you get 5 here. So we expand and we equate. So 3 times 2x, you see, we have 3 left here now. 3 times 2x, we have 6x. 3 times negative 3, we have negative 9. Don't forget this minus. Minus 5x times x. We get minus 5x. Is lesser or equal to, lesser than or equal to 2 times 50, we get 30. Two times 50, we get 30. So we collect like terms. Remember, this and this are on the same side. This 5x and this 6x, they are on the same side. So the signs are not going to change. So we just write 6x minus 5x. So those say, oh, why do you write minus? It's supposed to become plus. It's still minus because they are all on the same left side. It's not coming from the right. If it's coming from the right side, the sign will change. So we just say 6 minus 5x is lesser than or equal to 30. When this one comes this way, it becomes plus 9. Because you see the 9 and the sign change because it goes all the way to the right. So 6 minus 5x, 6x minus 5x, we get x. 1x is same as x. It's lesser than or equal to 30 plus 9 becomes 39. So this is it for this inequality. So the integers are from 0 to 39, all the whole number, positive integers. The positive integers. But this question didn't ask for it, it just solve x equals to 39. X is lesser than or equal to 39. See, x is lesser than or equal to 39. So that's that for that. Let's see another question. Before you get tired, eventually let's do at least as many as we can. Okay, let's see this question. List all the prime numbers which satisfy this inequality. Okay, we have to solve the inequality first, and then we now list the prime numbers that probably will satisfy this inequality. So we say 16 is less than 2x minus 5. 16. Okay, this is a double inequality. 16. Question number 15. Is it 16? 16 is less than 2x minus 5 less than 48. It's less than 2x minus 5 then less than 48. So this is a double inequality. So what we do what we know how to do best, right? We break it to two inequality. On the right we have this. Then on the left, let's use a different color. On the left we have this, so that it should not be confusing. So we break it to two. So we write the left one out. The left one is 16 less than 2x minus 5. Minus 5. Okay, now let's see the right one. The right inequality is 2x minus 5 is less than 48. So we solve them individually. So we collect like terms on the right. Look at the right. We take this negative 5 to join this place, become positive 5. So we have 2x is less than, we bring this negative 5 to the right side, become 48 plus 5. 48 plus 5. So you have 2x is less than, 48 plus 5 would be 53, right? 53. Then that's 2x. So x will be what? Divide both sides by 2. X will be less than 53 divided by 2. 26.5, right? 3 divided by 2. X will be less than, I think, 26.5. Now let's see on the left side, the inequality. You have 16. Bring the negative 5 to the right, it becomes positive 5. is less than 2x. If you add this and this together, you get 21. 21 is less than 2x. Okay, I think we should have used a different color. Say 21 is less than 2x. So we divide both sides by 2 in order to find our x. So x, divide this by this, you get x. Divide 21 by 2, you get 10.5. So we bring them together. So we have x. We write x, this one. Then to the right, we have less than 26.5. We have 26.5. Then on this side, on the left side, you have 10.5. And the question says we should find the prime numbers, right? So we're going to list all the prime numbers between 10 to 26. That's what we're going to list. Prime numbers. Is 11 a prime number? Yes. Right? 11 is a prime number. Right? Are you with me?
Yeah.
11 is a prime number, right? Prime numbers are those numbers that can only be divided by itself and 1 only, without a remainder. 11 is a prime number, right?
Yeah.
Okay. So we list them. 11 is a prime number. They want us to list all the prime number. After solving this, you have to list the prime number within this contest. Within this contest, between 10.5 to 26.5. So 11 is a prime number. 30 is a prime number, right? 30 is a prime number. 50 is not. 50 is not a prime number because 3 can divide 50, 5 can divide 15. 17, is 17 a prime number? Yes. So 17 is a prime number. So you list 17. 70 is a prime number. 90 is a prime number, right? So we list 19. 21 is not. 21 is not a prime number because 3 can divide 21. 7 can also divide 21. 23 is a prime number, so we list 23. 25 is not. 5 can divide 25. 26 is not. If an even number, 2 is the only even number that is a prime number. Only 2. 2 is the only even number. All those 4, 6, 8, 10, 12, none of them is a prime number. Till the end of numbers, only 2 is the even number that is a prime number. So the other prime numbers, they lie in the odd numbers. They only lie in the odd numbers. You only be checking the odd numbers. So these are the prime numbers: 11, 30, 17, 19, 23. These are the prime number for this question after solving this inequality. Is that okay? See them?
Yeah.
11, see? Can you see? 11, 13, 17, 19, and 23. These are the prime numbers. Okay? Okay. Let's just do try for the next 10 minutes, right? Or 10 to 15 minutes. Then we'll close this section. Is that okay?
Please make it 10 minutes.
10 minutes, okay. Okay. So it's a x and y are integers. X and y are integers. Find the value of x when, okay, x and y are integers. Integers means whole numbers. X and y are integers. Find the value of x when minus 7, x is lesser than minus 5 and greater than negative 7. Then in that case, it will be negative 6. X is less than negative 5, a number that is less than negative 5 and is greater than -7 will be -6. So this answer, you don't, that's why it's just 1 mark for Cambridge IGCSE. So it's just -6. So the solution, this one you don't need to do anything much. Look at, if you follow the story, x and y are integers. It says find the value of x when -7 is less than x less than, okay, x is less than, you know the way you read this inequality, you read from x to the right before you read to the left. You say x is less than -5, meaning it's smaller than -5 but greater than -7. What number would that be? -6 is greater than -7 in negative numbers. You know, right? In negative numbers, -6 is greater than -7, but it's less than -5. So the answer to this question is x equal to -6. Are you with me? Well, let me show it. Question number 16. X is less than -5. See, in inequality, we read to the right before we read to the left, and then greater than -7. Okay, what is the integer value of x? You know, I told you both positive and negative numbers are integers. As long as it's a whole number, they are integers. So we have positive integers, we have negative integers. So x is less than -5, but greater than -7. Therefore, x equal to what? X will be equivalent to -6. Because if you put -6 here, -6 is less than -5. That's correct, right? And -6 is greater than -7. That's correct, right? Are you with me?
Yeah.
Yeah, this question you don't need to like, that's why it's just 1 mark. You don't need to like, it's just an intuitive question. Now it's a find the value of y when 3/4 is less than y over 16 and is less than 7/8. Okay, it says you should find the value of y. So what we can do is to like take the first 2 and find y. So what I mean by that is to say 3/4 is less than y over 16. Let's write the full question and then we solve. Three over 4 is less than y over 16 and is less than 7/8. Find the value of y. It's less than 7/8. So we can actually do this first. Okay, by say 3/4 is less than y over 16. So we can cross multiply. You can take this numerator to multiply this denominator, and you take this denominator to multiply this numerator. Because this one is acting, this lesser that is acting as equal to it. It's as if, you know the way we used to have equal to in the algebraic fraction. So if we cross multiply 4 times y, you have 4y. It's less than 3 times 16. It's 48, right? 48. So 3 times 6 is 48, and 4 times y is 4y. So if I divide here by 4, y will be equal to what? Divide both sides by 4, y will be equal to, or y will be less than 12, right? 12. Y will be less than 12. So this place is 12. Y is less than 12. Is that okay?
Yeah.
Okay, y will be greater than 12. Sorry, will be greater than 12. So which means from 13. Y will be greater than 12, which is 13. This one is -6. That's correct. Okay, we still got time, right? How many minutes we have left?
4, I think.
4. Okay. Do you want to try this one? This one is very easy. This one. You want to try? Just like trying.
Can you do it? Because I don't have a paper to do it.
What happened? Why did you take paper today?
I'll practice. I'll practice later.
Okay.
and show you.
I'll send you the video also. Okay?
Okay.
Yeah. So we have question 18. Question 18. We have 3x minus 1 is lesser than or equal to 11 plus 2. We have 3x minus 1 is lesser than or equal to 11 plus 2. Is it 11 plus 2? 11x plus 2. Yeah. 11x plus 2. So we do like as usual, we collect like terms. We bring the one with x to one side. So we say 3x. If you bring 11x here, become minus 11x. Become minus 11x. It's lesser than or equal to 2. This -1 comes here, become plus 1. 3x minus 11x, what do you get? -8, right? -8x. Right? Yeah. We get -8x is lesser than or equal to 3. Now we're looking for x. We have to divide both sides by -8. So remember what I said, if you divide by negative, the sign will change. So -8x divided by -8. This one will become greater than. It was lesser than before, it become greater than 3 divided by -8. So anytime we divide by negative, this inequality sign will change to the opposite one. So we have x left here greater than or equal to -3/8. You can leave your answer in decimal or leave in this fraction. Okay, so that's that for this question. So you can leave answer, you see, x is greater than or equal to -3/8. So you can leave the answer like that, or you in fraction or in decimal. Whichever one is fine. Now let's take a look at another one. Oh, we should end it. Let's solve this one more question. Right? Hello?
Okay.
Yeah, this one more question. But actually, not for time, I think we should have finished on it. But at least all we have solved, they stand for all the different types of problem you will see. That's the good news. The good news is that all the questions we solve, if you follow them in details, they will stand for any questions that will come out from inequality. So let's just do this last one and we call it a day. So we say 6x plus 3 is less than x. Question number 19. Six x plus 3 is less than x. Six x plus 3 is less than x, less than 3x plus 9. Less than 3x plus 9. So like I said, we split. This is the last one, please pay attention. We split it to two inequality. Okay, the other inequality from here. So we do them one after the other. We say x is less than 3x plus 9. Here we have 6x plus 3 is less than x. So let's collect like terms. So we'll bring this one here, become x minus 3x less than 9. X minus 3x we get negative 2x less than 9. If you divide both sides by negative 2, divide both sides by negative 2, and anytime you divide by negative, the sign will change. So we have x is now greater than 9. Greater than negative 4.5. So if you say x is greater than negative 4.5, it could also mean negative 4.5 is less than x. So whichever one you say negative 4.5 is less than x. They are same thing. These two things, they are same thing. These two things are same. Now let's see what is happening on the left. We say 6x. You bring the x to this way, become minus x. It's less than, you bring this positive 3 to the right, it become negative 3. So 6x minus x, it becomes 5x. 5x is less than negative 3. So divide both sides by 5. So you say 5x over 5 is less than negative 3 over 5. It's less than negative 3 over 5. So 5 will cancel 5. Remember, we are dividing with positive 5, so the sign will not change. So we say x remain here. X is less than negative 3 over 5 will be negative 0.6 if you change to decimal. So x is less than negative 0.6 and greater than this. So if you want to merge them, this one will be on the right now, because this is x is or you say x is greater than negative 4.5 and less than this, and less than this one. So it's up to you which one you want to write first. If you want to write like this, you say x is greater than negative 4.5 if you want to use this way. S is greater than negative 4.5 and less than negative 0.6. If we put them together. Okay, so this is the solution. Is that okay? Or you use the other way around. If you're using the other way around, then this one comes first, and it becomes, instead of greater than, it becomes lesser than. So let's see. Okay, they just want you to list the integers. It says solve this one. Oh, for the integer values. They want the integer values. So what are the integer values? After solving this, you have negative 1 to negative 4. Right? After solving this, you have negative 1 to negative 4. So I think we stop here for today, right?